Now we are going to look at the vertical method of adding and subtracting polynomials. If I have this polynomial and this polynomial, they both have lots of different terms. They could be in standard form, but this one is not. They could already have all of their like terms combined, but these polynomials do not, because like 4x squared minus x squared, we could combine them first, but I'm going to show you the way that you can just do this the vertical method. What you're going to do, first of all, since it is a subtraction problem, we want to go ahead and use the distributive property here. So we're really multiplying everything in here by -1. When you multiply everything by -1, it just changes the sign of everything. So this becomes plus, this becomes minus, 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 and plus. So now we are going to look at the polynomial with the biggest term, and we're going to make a column for every degree of the term. I'm sorry, I meant the biggest degree, not the biggest term. All right, so the first one is going to be this x to the fourth. So I have one right here, which is a negative, and I have one right here, which is a negative, right? So I'm going to start negative 6x to the fourth. Now, any other x to the fourths that I need to add, I'll put underneath it. So this will be negative x to the fourth, and if you want to, you may write negative 1x to the fourth. Okay, so I've done those two. Now I'm going to put a space for the x to the cubed. Now, if I don't have any x cubes, I don't have to do that, but I don't have any x cubed here, but I do over here. So over here, I can either leave a blank, or I can just put 0x cubed here, because I didn't have any in this first polynomial. Or you can just leave it blank as long as you keep your columns straight. So I'm going to put this positive 1x cubed down here. Okay, I did that one. Now let's go to our next highest degree, which would be the x squared. So I have a 5x squared and I have a 4x squared, so I can put that here. If I wanted to, I could have just put 9x squared here, or I can put them all in a column. And I don't have any more x squared here. Oh wait, there's one more x squared, minus 1x squared. So I'm going to put that down here, minus 1x squared. And now I go to my x to the first power, so this is plus negative 2x. I don't have anything underneath it. If you want to line up your columns, you can put plus 0x, but you don't have to do that. And so I'll put that one down. And now the only terms that I have left are all my constants. I have a plus 7, I have a plus -1, and I have a plus -5. Now I just draw a line under all of these, and I add each one. This is negative 7x to the fourth, plus, I don't write the 1 here, I just leave it as x cubed, plus x cubed. 5 plus 4 minus 1, that would give me 8x squared. And then the -2, and I could put a 0x here too if I wanted to, but I don't have to. Plus -2x, or I could have said minus 2x. And then here I've got two negatives, so those are -6 with a positive 7. That gives me plus 1. This is the answer to my question. Sometimes you'll want to solve these using the vertical method. Sometimes it'll be easier to use the horizontal method. You need to understand how to do both.